Good afternoon, everybody. My name is Jim Hassman. I am the Group Vice President of our Industrial and Manufacturing practice at C3. And just so I know who's in the audience, how many of you are from IT? Okay, I did one of these yesterday. That was about the same number. How about business? Okay, a few. How many data scientists do we have here? All right, a little more than yesterday. Great. Okay, so the topic is faster, better, cheaper AI apps in 1/10 the time and cost. So what I'm going to do is provide a little background on C3, what we offer to the market, what type of customers we're working with, and a little bit about the subject line of this session. How can we validate that that is actually true? And so I'll go through that a little bit. I'll go for about 20-25 minutes, and then I'm going to turn the remainder of the time over to one of our customers. Julian from NG has come all the way from Paris to talk to you, so thank you for coming and sharing your noon hour with us. Just a little bit about C3. We are a software company, and I would say our core focus area is helping companies with very large, very complex business problems where AI can actually enable those to unlock substantial economic benefit. And the question we always ask is, why work on that use case? Why do it now? Why do it with C3? And those are the questions we try to help customers answer. We typically say no to a lot of ideas where the economics are really hard to quantify. Not that our customers can't use our platform and our technology to go work on those and to kind of discover the art of the possible, but we as a company are hyper-focused on solving very substantial business problems using AI. And I'll talk about the speed at which we can help your company do that. We're not a hardware company, so I'll just make that statement. If you can touch it or see it or hold it, we don't make it. Okay, everything we do is software. And we live at the intersection of elastic scale cloud computing, big data, the Internet of Things. AI and machine learning is really one of our core competencies. Someone from AWS about 2 years ago coined the phrase, C3 are the plumbers of AI. And I thought it was an interesting tagline. It never took hold in any of our slides, but I liked it, so I use it from time to time. Our sale as a company is actually at the senior levels of these customers that I'll show you at the end of my presentation. Why? Because they are the ones that are looking at how to transform the business and stay competitive. They have hundreds, if not thousands, of areas within the business that if touched by AI, could actually make them more competitive, could actually change the way people work. And I would say maybe that's a fourth question we ask is, if we're not working on a project that isn't changing the way humans do work, why do it? Because you could solve a great technology problem, but if you don't change the way people work, you will never get the benefit. These are the types of use cases that we have worked on to date, or you could call them applications if you want to. Predictive maintenance has been the killer app for us, and we've found many ways to help customers with both the predictive and the prescriptive component of predictive maintenance. Inventory optimization. We've done a lot of work in oil and gas. We've done a lot of work in healthcare, financial services, federal government. I focus predominantly on industrial manufacturing customers, but I find myself in conversations with companies from other sectors as well. We, as a company, state that we are the leading provider of big data, IoT, and AI applications. This is founded upon the number of customers we have with large-scale, enterprise-wide production deployments. This is different than somebody that may be creating tabs on the number of proof of concepts they've done. And some of you would agree that you live in kind of this POC purgatory, and you can never get out of that. You're constantly trying things, but it never moves to production. You never get end users using it. And if that doesn't happen, you never get the benefit. We provide a platform as a service. We are a data integration platform, and the speed at which we can do integrations is quite remarkable. We are a rapid application development platform. We're massively scalable and distributed processing platform. We're low risk, tried, tested, proven, and I like to use the word hardened. When you look at the number of companies where we have deployed this platform and helped them build applications for their business, there are things that you cannot replicate in a POC setting that you would find doing this in production across so many large-scale companies. And that really takes the shape and helps harden what we call a platform. We've spent about 9 years doing this. We were founded in 2009 by Tom Siebel, who, as you guys know, was early on at Oracle, founded Siebel Systems, and then this is his third major venture in his career. We've invested about $400 million to date in the engineering side of this platform, and this actually has a direct impact on the ability of how fast you can build apps and do data science work using C3. Our core IP of this platform is about 1 million lines of Java code that create a metadata-driven abstraction layer between the application developers and data scientists and the underlying services or technologies that the platform utilizes. We believe that if there is a good technology that can be used underneath to make the platform better, we would rather use it than try to build it ourselves. But this 1 million lines of Java code actually allows us to plug things in and out very, very seamlessly without affecting the applications that our customers have developed. This is the platform, or a picture of it. I know it's some of the words are hard to see, but I'll go through this in a little bit of detail. I have some slides that break this down. Really, there's kind of 4 major components. One is the data integrator. Our philosophy in doing data integration is we don't know what kind of data we're going to run into. We're selling to very large, complex customers that are typically global at scale, customers who have a wide range of services and products they make, companies who acquire other companies who bring legacy IT with them. And so we really focused our data integration efforts on what is the way that we can create a common transformation layer between any source data and the C3 platform that is going to consume that data, normalize it, aggregate it, federate it, keep that data image current in real time or no real time. And so that's the first component. It's actually when I got hired in 2010, that's what I got to work on. And there's still a very large product team that focuses on that today. The second component is the big blue box in the middle. And this is what we call the platform. This is what contains all of the necessary platform services that you see on the bottom. This would be, authentication, encryption at rest, encryption in motion, queuing, logging, profiling, all those things that you have to basically make sure the platform is robust, performant, secure, and reliable. Moving up the stack, data virtualization. A common question we get from companies is, do I have to move all of my data into C3 to be able to use it? The answer is no. There are a lot of data that end up in C3 because it's been optimized to really do AI and application development. But there are some cases where customers have, external data sources that, they've made a big investment in. They've got good governance on that data. People use it. The data has value. And we can actually virtualize those data sources without bringing them into the platform. Third, moving up the stack is what we call continuous data processing. So any of you that worked in the world of Hadoop or MapReduce jobs, you all understand that in order to keep the analytics current, you basically have to put all the data into 1 million pots and keep them boiling all the time. That's an expensive proposition. In its time, it was state of the art, but there are better, more efficient ways to actually leverage elastic scale cloud computing today, and we have built that into our platform. An example would be as a set of data arrive, the platform is intelligent enough to know that conditions have been met, and I need to actually trigger the analytics to fire for those things, always when those conditions are met, but only when they're met. And so that all of the analytics that you have in this platform are always current given the state of the nature of data delivery. And so that really helps maximize both the processing, the performance, and the cost of running this type of architecture in the cloud. Moving up even further is the AI and machine learning capabilities of the platform. We have a few data scientists here today. I think if you sample the group across this conference, you'll find that there's a variety of frameworks they like to use. There's a variety of languages they like to use or are comfortable with. And so we took the approach of we want data scientists to be able to use what's comfortable to them in this platform. We actually bring in all of the open source libraries that one might need to do data science work. We allow data scientists to connect the various notebooks using different languages that they like to the C3 environment and actually develop their models on all of the production data. I'm going to pause there and let that sink in. They develop their models on all of the production data. Why do we do that? Well, that first slide that had that circle that had big data on there, one of the limitations for data scientists today is they're typically working with a subset of data. So there's a sampling error in their models from day one, from the time they start. We said if we could actually improve their experience without affecting production workloads, let's do that. And so they can connect their IPython Jupyter Notebook or RStudio or what have you to the C3 platform environment, authenticate, and get all of the data, all the analytics that are there, build their models, and train them on production. This removes the sampling error. And when they're done, what's really cool is they can save their models as a RESTful interface. The benefit of that is nobody else has to go back and try to recode their work to turn it into production application. Over on the right-hand side are apps or examples of applications. I don't know how many apps our customers have built in total. We've built a bunch that we take to market that our customers can use to start with, like predictive maintenance, inventory optimization, sensor health, anti-money laundering, whatever. But our customers are building way more apps than we are, and they're leveraging those application packages potentially as a starting point for both data models, for analytics, and apps development, and extending off of those or creating entirely new ones. All of those scenarios are fine. And then at the top, we've invested pretty heavily in tooling. There's various classes of developers out there. Some people really like code. Some people like GUI. And we have both of those states for business analysts, for application developers, data integration engineers, data scientists, and even other systems that may want to consume from the C3 platform, and I'll give an example of that later on. On AWS, you're all here at the AWS conference, so I want to explain how this ties in. We can deploy this platform into your AWS account, okay? So it's in your VPC. It's wrapped with your security. We go through all the audits and things that the security people like to do to make sure that it is robust, secure, and performant. Underneath, we are utilizing many of the services that Amazon provides. So if you think of the state today, what you might do is say, okay, we have this problem to solve. Here's a bunch of Legos provided by Amazon. We need to figure out how to put these things together and so that we can go solve this business problem. C3 takes care of that for you. When I talk about the plumbing, we built a feature of this platform, which is our core IP, called the C3 type system. It's the big orange box that kind of wraps this whole thing. Types are basically metadata, and we connect the Amazon services via metadata. So they look like APIs to us. So as Amazon comes out with more and more services, and or you want to include services from open source or other providers, we can make that possible for you very, very quickly. The benefit of doing that is that you're not hard coding any of your business logic to the underlying services. You never write SQL code. You never write CQL code. You interact with the type system. And the type system says, what am I and where do I need to go to get what I need to get and what do I need to calculate? As services underneath change, and Amazon will continue to come out with new services and other services out in the market, we can actually replace and or add to the underlying services mix of this platform so that you're not locked into yesterday's technology decisions. As you do that, the type system keeps your applications from breaking. Because it's metadata driven, we can actually change the underlying infrastructure without breaking the apps. We can change the underlying infrastructure without breaking the data science models. All of this would be brain surgery in any other architecture. So this is kind of a depiction of the type system. It sits between the data integration, application engineers, data scientists, business analysts, or other systems. And it is the language and communicator that communicates to all the underlying services, in this case, Amazon. So I'll quickly go through some of these slides because I want to get time for Julian to come up here. But some of these are on our website, but I would say the C3 type system is the heart of what we do. And nobody else has it. It's what makes us go fast. It basically allows us to do the integration layer. It allows us to create objects with functions and methods on them. It allows us to create analytics and allows us to create AI models, all of which are RESTful APIs. The benefit of that is you have a massive catalog of data analytics and models that can be consumed by anything. You can build apps on C3 and consume them. You can have other services and systems that consume them. I've got a customer that has SAP Hybris as a front end for their end consumer, their customer, which is their dealers. And they've been using Hybris for years to do ordering. Well, they didn't want to change the front end, but they needed a very sophisticated matching algorithm for the types of machines they sell. All of that is in C3, fed by about 20 different data sources from that customer. The algorithms run and provide the RESTful interface that SAP calls. So we don't really care what the UI is. We have our own UI framework, but you can use anything you want. We use a canonical object model for data integration. We support a variety of different data integrations or technologies. We can support a variety of different data types. The platform services I mentioned, so I'll skip through that in the beginning. I skipped through data processing a little bit, or talked about that earlier. I talked about AI. Some of the tools. We actually have a graphical data science tool called Ex Machina, which is on here. This is similar to SageMaker, but it's already pre-integrated to Spark, sits on the platform, and is a visual way for, I would say, a business analyst to start to get into the world of data science. The hardcore data scientists still like Python, or they like R. This is really for somebody who's emerging into the field of data science. For building UI, or for writing code, you can use Eclipse IDE plugin, you can use Jupyter, you can use RStudio. The C3 platform is a polyglot system. If I want to write in Java, fine. JavaScript, fine. C, fine, whatever. It doesn't care. Python, it saves everything as a type, and on execution runs and provides a result back. Data visualization, you can use ours, you can use Angular, you can use React, you can use Power BI. We don't care, right? There's a lot of ways to do UIs. So here's the question. You're all here to learn about how can you do this in 1/10 the time and cost. What does it take to build a simple app? Well, Hello World is probably the most simple app ever built. Many of you guys have done this. Ours is predictive maintenance for smart light bulbs. So if an application engineer was going to build this app, what is the fastest way they could do it? So this is what we give our customers, developers who come to C3 for training, is they basically go through these 5 steps. They gather the data from 5 data sources. They create a data model for about 1 million light bulbs going back the last 2 years that have 15-minute interval data. They enrich the data and develop analytics, or for you data scientists, this is feature development. They create a predictive analytics AI model. For you data scientists, this is a machine learning classifier. And they develop an application with 4 user interface screens that can achieve the goal of predicting with 80% precision and 70% recall the state of these light bulbs. So pretty simple. We give them a URL. They spend 0 hours putting these Legos together, so 0 hours on infrastructure. And that would be the case for any of you using C3. You can start building apps on day 1. They spend about an hour on the ingest model, 5 hours on data model, 20 hours on application and UI, and about 14 hours on the machine learning component. Most of these developers that come through training have never actually built a machine learning classifier. This is their first time. So even so, they can do this in about 5 person days at the cost of about $2,000 for that resource. This is what the application looks like. It's got summary indicators for the 1 million light bulbs. It's got a histogram that shows the risk of each light bulb. It's got a risk distribution of each of the light bulbs, and you can drill into that and see which light bulbs are at risk and why. And it shows these geospatially. As they bring these data in, there's lat-long data on these light bulbs, and we have third-party services that go out and do all the mapping for them. They don't have to build that. We do the same thing with weather. And the details for each light bulb. So allowing an analyst to actually see why is the performance of this light bulb degrading. And there's a lot of applications if you think of this in a commercial or an industrial context as well. You can actually get down into the individual time series data for each of these, the lumens, the hours on, the hours off, the temperature, what have you. And this needs to run on AWS. And so that's the assignment. They can complete this in a week. The antithesis is build this yourself without C3. So what does that look like? We actually sent a product spec for this application, which is very simple. It may be the most degenerate predictive maintenance application there is. The product specification is 16 pages. We gave it to the top 2 AWS software integrators. All these companies do is put Legos together and help customers, AWS customers, build AWS platforms. This was the architecture they gave us. This was the effort in total man-hours they gave us to build this application. 5 people, 375 person days at the cost of almost $600,000. They estimate that when they complete this effort, and we're actually paying them to do this right now, so I think next year we'll be able to show you the results of their effort here. They estimate about 12,700 lines of code. Our students build the same application in 650 lines of code. So real quick, we're not a science experiment. We're not just a data visualization tool. We're not a closed black box environment. We're not a replacement for existing installed enterprise systems, and in some cases, not even a replacement for existing data lakes. Our first thought as we approach business problems is what can we leverage? We're not a rip and replace organization. These are the customers that we are, or a sampling of customers that we are deployed at today. What you'll notice here, most of these are very large, very big, very complex organizations, and there's not one of these companies where our executives and their executives are not on speed dial with each other. So our relationships with these companies are intimate. Why? Because they are embarking on something that is completely transformative to their business. And so from the executive level, the business units within the business, and the digital teams and IT teams that support these efforts, we are tied in from top to bottom. Those relationships take a while to develop, but you would be amazed at the speed at which some of these companies are developing apps. I was at an executive briefing right before Thanksgiving with 3M, and one of the applications they showed was a sourcing price optimization application. They built this app in 4 weeks and demoed it to their executives in that executive briefing. The executives went to the front of the room. They were poking, click on this, show me this. And they said, how long would it have taken you all to build this if you didn't have the C3 platform? The answer from the development team was 2 years, and we're not sure we could have actually finished it. So I'm going to pause there. My only ask of you is that if you haven't had C3 come to your company and do a briefing or come to visit us in California, I would love to help make that happen. It's a rock we're turning over and understanding what we do and how we do it. Even if you don't do anything with us, I think it's worth your while to understand what we have going on. So with that, I'm done with my part of the presentation. We'll take questions at the end. I'm going to turn it over to Julian from NG.
Thank you. Hi, my name is Julien. I'm from France, as you may know, not know. So does anyone know NG in the room? No, no one. Okay, so ENGIE is one of the biggest utility company in the world, so it's a French-based company. So here are the key figures. So it's a $65 billion revenue company, billion euros, sorry. 153,000 people working there, and we are the first producer of electricity in the world, okay? So we have subsidiaries in the US, of course, in South America, in Asia, and all over Europe. So, and we cover more than 70 countries. So we are not a software company, so it's very important. Out of the 150,000 people, maybe you have 1,000 software engineers. So you can see the ratio, it's a very small amount of people. So the idea is how can we accelerate the digital transformation? Because for us, this is a key point. Just to give you an example, I was hired like 4 years ago by NG, and when I came in, there are like many projects, maybe on like 300 POC, some other project, and basically they were doing everybody was doing the same. So basically, what do you want to do? You want to do data acquisition from your assets or from like the customer you have. You want to store those data. So you have two types of data. You have time series-based data, and you have like kind of CRM data. And then you want to provide analytics. So we've built many platforms. So one was with MySQL and MySQL and some Perl analytics code-based. You can guess that it was not very efficient. So the idea was to find some software companies able to help us to accelerate our transformation and also to be able to make real product. So that was part of the strategy of the group. So here is a slide which shows you that in 2016, there was the CDO was appointed. His name is Yves Le Gélard. And then we create a subsidiary called NG Digital. So it's based in Paris, and the idea was really like to take some software bricks and to build them quickly. So we chose first AWS. We also have our private cloud. We spent €1 billion for our private cloud. Everything was rid of. We just put aside. So we get on AWS. And then it's not enough, because you need to have like, as we are not like a software company again, we need to have like some other bricks on top of AWS. So here comes C3 in the loop in order to help us to accelerate the production of software around analytics. So we started to build a common COE, so it's a center of excellence in Paris, with a mixed team of NG engineers and C3 engineers. And so why choosing C3? It's because we have several fields within NG. So we have gas, we have electricity, we are producing electricity with wind turbine, hydro, so it's all the renewable assets. But also we use all thermal assets, gas turbine. We are also in the field of the smart cities. We work in Rio, Singapore for smart cities. We also are in the B2C market field. We're in the service fields. So we are in a lot of different kind of services. And C3, for us, it's a key component because it allows us to address all those kind of different fields we need to get on. So here's the team we've built. So it's roughly like 20 people, so half from C3 and from NG. We started 2016. Before that, we were not able to produce, as he was saying, it took 1 year, 2 years to build something around data analytics. So we started in parallel, I think, 3-4 projects. And within 6 months, we were able to finish them, to put them in production, and then take new projects. So this is what you can see here, that we now are able at full space to deploy 3 new applications every 6 months with a team of 20 people. So when I mean a team of 20 people, you have data scientists, application developers, data engineers, 1 delivery or 2 delivery managers, and also ops. Okay. So now on the platform, we have roughly 1 million sensors. So when I mean sensors, it's real digital devices such as LoRa, Sigfox, for those who are familiar with. These are small sensors you can put everywhere and can give you back data such as humidity, temperature, any kind of data. And overall, we have 5 million endpoints. So an endpoint could be a bill. So a bill for us is an endpoint of data. So now we are acquiring 17 million measurements a day. So it's not like a huge amount of data, but it's a start. And annually now we have 25 terawatt hour annually being analyzed by the platform. So this is the annual consumption of Republic of Ireland, so which is something now. So it's a real platform now. It's not like a POC. It's really something which is now in-house very important for us. So it's becoming more and more strategic. So now I will give you some example of what we are doing with the platform. So I mean with the C3 platform plus the AWS environment. So the first one is called Darwin. So Darwin is our renewable platform. And the idea is to optimize the production of energy. So it's a good thing for our future because our CIO wants really like to put a lot of effort in the renewable energy production. So first we started with wind turbines. So we started the project and I think that was last year, and it took us like 12 weeks to make our first version. So for the moment, the real figure, so the 2,000 wind turbines, it will be like by the end of next year. But for the moment, we have almost like 400 wind turbines covered, which means that we have 11 million data points integrated, and it represents like 5 gigawatt of power. So one wind turbine usually is about 1.5 megawatt per hour. Okay, so I know you're not familiar with the utility world, but it's just to give you some figures. So what we do apply here, we take the data of those wind turbines, and we try to optimize the production of those wind turbines. So there is first thing we use the machine learning algorithm provided by the C3 layer. So we have a bunch of data scientists. They are directly connected to the production environment. They can take any set of data they want. They do their training. So we have one model per wind turbine. So it means that if you have 2,000 wind turbines, we run like 2,000 models every day, which is huge. And we deploy the models in parallel using many workers. So we do have, so for those models, then we apply underperformance. So it checks if the wind turbine is underperforming or not compared to the theoretical production curves. And we also have two other machine learning algorithms. One is for ice detection for the northern part of Europe, because you have to detect ice and to stop the wind turbine if there is a suspicion of ice on it. And the other one is for predictive maintenance. It's the main bearing temperature. So if there is an issue, and if there is an over temperature of the main bearing, then we can set someone to check the installation. And with that, we're increasing the performance by 2-3%. And the forecast of economic value is about like 15 million euro. So you can imagine that it's huge. It's not like a small amount of money, it's a big amount of money. Even if we are a very large company, it's very important for us like to find like new business model, new revenues. So this is the forecast. So we will connect all the wind turbines we have by the end of the year. And next year, we'll start to connect also the solar plants we have. So we have a lot in the US. And we also have like 10 hydro plants we will connect in Europe. So this is the overview of the solution. So what we use, so we gather data from the field. So we have the metadata of the wind turbine, which are the description of a wind turbine. So the plant of wind turbine could be different because all the wind turbines are not the same. But you need to find a common data model in order for the data scientists to be able to compare apple to apple. Because if you just take the measurement of your time series and you want to start machine learning, you need to have a common definition amongst all the company of a specific data model, which is representing uniquely your wind turbine. So this is very important. So if you work on such field, you have to think of that. So on the right side, you can see the web application we've built to monitor in real time the fleet of the wind turbines, where you can also have the real-time production, the wind speed in real time, etc. Okay, the second use case, so you see we have different stuff, is in the district heating and cooling network. So I don't know if, I think in the US you have a lot as well. So the idea here is to optimize the coefficient of performance of a steam production plant. So in order to put the steam in the district heating and cooling network, you have a complex plant which is producing the steam. And here is also an interesting use case. Why? Because first, it's a very engineering stuff, this kind of production. So you have a heat engineering system with physical models, etc. And then after a few years, the model is getting more and more complex. Why? Because you are adding some wind turbines as well, to feed the plant. You put geothermy, you add more valve, and at the end, you're not able to understand anymore the complexity of the plant. So here is why we applied machine learning. Because once you cannot go back to equation, like a physical equation, then you can apply the machine learning to understand what's happening on your plant. And this is what we have done. So we did this project in 24 weeks. We have 300 type of sensor for each plant, usually. And we do 15 minutes data interval. And so we are saving, again, 2 to 3% in the consumption cost. So here, I will go on this one. So the idea is to have a look at the historical data. So the idea is you have 300 features, and you want to check by using some constraints what could be the window I need to use in order to optimize the production of my steam. So let's say you have two different values. One could be the temperature of a system, and the other could be the percentage opening of a valve. So your constraint is I want to operate my plant between let's say 80 degrees and 100 degrees Fahrenheit. What should be the optimum position of the valve? So this is what the solution is doing. And it gives you a result. And then the operation plant engineer can change the position of the valve in order to optimize the production of the steam. So this is the result, and this is the kind of screens where and everything is accessible through its web application. Okay, this one is so anyone does not. Ohio State University, I guess. So it's one of the biggest university in US. This is what I've been told. So I've been there already. So we have won a big contract for energy efficiency management. So which means that we will provide energy for the whole campus. And we need to also be able to decrease the consumption every year of of all the buildings. So first step, of course, is to analyze the energy consumption. So what we're doing, we are installing like smart meters in every buildings in order to get the consumption. And then the second step would be to apply some machine learning, depending on the data interval we will get. So if you get like minute interval data, you can do a lot of things, such as like disaggregation of electricity usage. But for the moment, we do have like 15-minute intervals. So the idea is to spare 25% of the energy within 10 years. So it seems huge, but actually it's easy. If we have signed this contract, we know we can do it. We provide also a dashboard for the students to give them sensitivity on the consumption of their building as well. And also we will rank the building, compare them to each other to make something like, I don't know how you can say that, but like to give a sense to the student, is my, I don't know, I'm usually going to this place, so is it really like over-consuming or under-consuming? So in red, this is the map of the Ohio State University. So you will have the over-consuming building and the under-consuming building in green. And the last use case, so it's called Mastermind. This is for the B2C market in France. So we are leader in the gas market with 10 million customers. And for electricity, we have 2.5 million customers. So you can imagine that we have a big IT department for the B2C market. And there is a rollout of a smart meter in France. And you have the electricity one and the gas one. And the idea is to, I think by 2 years, to have France covered only by smart meters. So you can have data, if you're a residential consumer, you can have one data every day, and you can have up to a data every 30 minutes. So here we start the project, and then it took us like 6 months because we have a very old IT system with some old SAP data to extract, and this is what was really like lasting for a long time. We are gathering like 8 million data points every month. And here the idea is not like to have an increase of income, but to retain the end consumer. Because if he's seeing the data every day, if you can see his consumption on a website, it's really like funny for him to see and more accurate than having a bill every 2 months, and it avoids also a bill shock for him. So far we have like 2.1 million customer linked to the platform. And here is, so you can see that on the left side, we are linked to different types of data. So you have SAP data. So I think it's all SAP instance because the columns are in German. So that was fun. We have also the data coming from the smart meter. It's not even in JSON. It's all the XML style fashion files. And the weather, okay, so this one is easy. It's a web API. So the idea is really like to present on the right side. It's small, but you can see your consumption per day, which is nice. And you can also see the bill per day. So the cost per kilowatt hour, the tax, the subscription. So you can really like have a precise sense of what is my consumption at home. And you can also compare your peer depending on the size of the house, and you can also check if you are over-consuming or under-consuming. So if you're like a green guy or not a green. Thank you. That was my presentation. So I know I was not too technical, but the idea is really like to give you a sense of what we can achieve in the real life.
So with those of you that are here, any questions? I think there's a microphone here, or you can shout out and we'll try to repeat it, but we have about 5 minutes for a few questions if anybody has questions. take 1 and 2 right here.
Just a question around the AI aspect. Using algorithms and AI to kind of analyze the data and to achieve cost savings. Could you maybe explain a scenario using AI and how it kind of helped you with some of the savings of costs?
Yes, for basically for the Darwin project. No, for the other one, for the Nemo, we used to have another type of tools, which was less efficient. So what we have done first is we took a bunch of like 2 data scientists for a month, and we just took the data out of the platform, and we just tried to reproduce. If we were able like to find a good way of optimizing the asset, okay? So there is no magic behind that. We use classifier, and this is a random tree forest, okay? And so this is what I call like a data science funnel, because I just wanted to spend a month to understand if we were able like to find added value out of that, okay? And once we knew that we were able to do that, then we go back to the C3 and AWS real world, really like to plug the algorithm. So the algorithm is written like in Python. They're using directly the production data through a Jupyter notebook, okay? So they can write the algorithm directly from the Jupyter notebook, and it's linked to the C3 data. So it's really like they can go back and forth, and once they're happy with the result, you put it's a kind of a zip file, the Python model. You put in production in the platform, in the C3 platform, and then you can run the model every day or every hour or every month. So the idea is you can really like update your model like every time it's required by the system. Before that, the issue we had is that we had like data scientists with RStudio on their laptop, and they were doing like work just on laptop. That was not like, and also what is really good that now it's like as it is web-based, they can spread out and share the data across the company. Because we have like some people working on wind turbines or some other assets in US, in Europe, in South America, in Asia. So they can share the data, they can share the same model, and they can enhance the algorithm they want to use.
In terms of savings, I worked on a project for a large manufacturer this last year. The problem was inventory optimization. There was no IoT data, it was all SAP data. But they'd spent about 2 years trying to solve that with Accenture and SAP and didn't get anywhere. They had a BI dashboard, but it didn't really do anything. And we solved that problem in 12 weeks. The economics of that using AI was $300 million. They carry about $1 billion in purchase parts. It was a $300 million instant reduction in optimizing every part that they had, and then annually it's $36 million annually to the bottom line. So. And that's evaluating, they run it monthly. It was initially set up to daily, but that was too much of a change for their buyers. So they run it monthly, and that's the economics they're getting for that right now. Question behind?
Is there any that exit plan, for example, if the model like changing after some kind of 5 years, the people just say that okay, I don't want to use this platform anymore. Is there any exit plan?
So if you want to port to something else? Yeah, okay, good question. This question comes up all the time. So a couple of answers here. Number one, there's nothing specific about the C3 platform that is tied to the underlying services. So first off, the architectures and services we choose today can change, right? So you're not locked into what you're running for relational data, distributed key value store, multidimensional data, whatever, right? Those can change without breaking the apps you've built. So that's one area that you're not locked into. In the area of the discussion around multi-cloud, we support that. We don't tout it at most of the conferences, but in customer meetings we do, so that's one area. As you build apps, or you build models, or you build types for the data, or you build analytics, if you were to port to something else, all of the metadata around those types, analytics, and models are yours, okay? The types themselves, which house the data, think of these as objects with functions, fields, and methods, those are yours. The data inside those types are yours. The models are yours. Now, the porting of that to something else is a question mark, right? And it's the same for any system. If you had a legacy ERP system, you moved to SAP, there's work there to port that stuff over, but all of the assets are yours. We have no interest in keeping your data or your types or your IP. So, any other questions? All right, well, thank you again for the professional courtesy of coming. We had a great time, and have a good conference.
Thank you.